Or kumusta naman yung proposals nyo? Research proposals. Do you have interesting proposals? Do you think interesting in proposals, no? At least? Wait now, where's that? Documents and files. Okay, let's see this. So review and statistics. So what do we know about statistics? Or at least what are our perceptions on the subject or on the field of statistics? Anyone, guys? So
Ano po sir, study of data po sir, or way of visually representing data.
ako na napaisip ko, we had a review elementary statistics before when I was in college, no? So that was 20 years ago, mga ganyan. So I would usually would think of, or I would remember statistics as the study of methods or of processes that are involved in handling data and or information. Pero data lang muna kasi pag information, process data, usually ang naisip ko na dyan is database or database management systems or information management, no? Pero data lang muna tayo. So before that, we will be siguro magandang thank you pala for the answer. We should siguro identify muna, differentiate quantitative data and qualitative data. For that, we have to, since our course or our subject is quantitative method, so we have to differentiate quantitative data versus qualitative data. Okay, before that, let's just have some review. Okay, so it's a project proposal nyo, we have to be able to identify a system to be modeled or simulated. Okay. Or computer system to be implemented. So you have to discuss if you're going to propose a project or a research project, a computer system to be implemented, you should answer the question how simulation can be used or be advantageous to your site, to your end. Okay. Okay. And or for your research proposal, you can do from scratch a game or from scratch an environment to be simulated. Okay. So yun lang, review lang for your research proposal. I-open ko ulit pala yun, just in case, up to May 7. Okay, so regarding quantitative methods, okay, what are the data that can be where we can use quantitative methods? So quantitative data lang ba? Okay, for some, qualitative data can be qualitative data, we can qualify it only, or pwede we can use the term, we can approximate it, or at least we qualify, we want to transform, or at least if possible to convert or to transform qualitative to quantitative data, then that would be nice so that we can use quantitative methods. Qualitative methods, okay, for qualitative data. Quantitative methods for quantitative data. So at least we should know how to uh, differentiate the two. Anyway, um, so ito yung topics na at least madidiscuss natin for this semester. Okay. So nandun pa lang tayo sa pangalawa. Wala pa tayo sa may apat pa. We will start pa lang sa pangalawa, sa stochastic process. Anyway, so as charting our topics that we will discuss in this course. So marami pa. Yung problem set, for sure hanggang verifying distribution siya. Yung problem set. Anyway, it's take home naman. And I would ask you to group into 2 to 3 members. Okay? Para you can work as a team solving a problem. Okay. So yun nga, quantitative versus qualitative variables. Okay. Which represents data. Okay. So from Corina Patel, so we have this topics. Okay, so unit of analysis, also referred to as cases, the most elementary part of which of what is being studied or observed. Some examples include individuals, households, court cases, countries, states, firms, industries, etc. Okay. Actually, almost anything can be used as, or can be our unit of analysis or our point of observation. Usually we would be dealing with finite data lang. But infinite data, well, it's possible. Okay. Of course, some would question, does infinity exist? Okay. Pero for example, in language, we have the clean closure operation of a language. Usually it's infinity, no? We would represent the clean closure of a language as infinity. Okay, that is under computer science naman. Anyway, usually we do finite data lang tayo. Variables, concepts, characteristics, or properties that can vary or change from one unit of analysis to another. Please note that all variables must vary. If there's no variation among the different cases, then it's not a variable. So it's constant, no? Some examples of variables include gender, social class, education, age, level of public enforcement, type of bankruptcy, etc. Okay, quantitative variables. Dependent variables which change the researcher wishes to explain. Independent variables that help explain the change in the dependent variable. Hypothesis. An empirical statement which seeks to test the relationship between at least two variables. For instance, level of public enforcement increases, levels of stock development also increases. This hypothesis has two variables. Public enforcement, dependent variable, stock development, dependent variable. The development in the stocks would depend on the public enforcement. So stock development is the dependent variable, and the public enforcement is the independent variable. Okay, we will try to categorize the variables. So we have the levels of measuring variables. The variable can be nominal. A nominal variable has qualitative categories that cannot be ranked in a meaningful way in terms of degree or magnitude. Examples of nominal variables include race, type of bankruptcy, type of corporation, name. Okay, all of these variables have qualitative categories that cannot be ordered in terms of magnitude or degree. So this is the least powerful type of variable. So alphabetizing the categories does not count. So footnote does not count as ordering the variable because ordering has to be in terms of degree or magnitude. So sorting, lexical ordering ng ating nominal variable does not count as uh, uh, does not count as ordering the variable. Okay. Because sa lexical order, not in terms of degree or magnitude. Kasi yung pag-lexical order natin, or yung pag-alphabetize, for example, or pagsusort ng ating nominal variable, so depends sa culture lang naman. So parang mauna yung A, followed by B, yung ganun. So African, followed by B, Balkan siguro, or so African, Asian, mga ganyan. So mauna yung African, then Asian. It's not really ordering the variable. It's just sorting the variable. Kasi ordering has to be in terms of degree or magnitude. So okay, so tapusin ko na lang to, ipapapasukin ko na lang yung second class. Okay, if you have other commitments, you may go. I'll just post the recording siguro. Share ko na lang mamaya. Okay, so papasukin ko lang yung second, yung 10:30 class. Sige, wait lang. Okay, wait lang. Okay, so ordinal variables. Excuse. Okay, let's continue. Ordinal variables. An ordinal variable has qualitative categories that are ordered in terms of degree or magnitude. Okay. Sige, I'll just minimize pala yung sa research ko.
Sir, nakamute ka po, sir. Sir, nakamute po ka, sir. Sir, hello. Nakamute po kayo, sir. Nakamute po kayo, sir.
Sige. So again, interval variable has quantitative values. Some example would be age, number of shares outstanding, and amount in debt. For all of these variables, the response is going to be a number or value. So yun yung interpolation. And then the fourth one, wait lang pala. One such restriction being the dependent variables, let's note it, being the dependent variable in regression analysis. In order to perform regression, your dependent variable must be a proper interval variable. Okay. So, dapat dependent variable ay interval variable. Okay, the fourth one, dichotomous or dummy. A dichotomous variable is a variable with two and only two categories. These categories can be qualitative or quantitative values. As a note, it is possible to convert nominal variables into numerous dichotomous dummy variable. Okay, so usually as far as I remember, there are usually two categories of statistics: scripted statistics and inferential statistics. Okay, but also we have multivariate statistics. Okay, for the scripted statistics, these are often used to describe variables. Scripted statistics are performed by analyzing one variable at a time, univariate analysis. All researchers perform these scripted statistics before beginning any type of data analysis. What do we use under the descriptive statistics? We usually have recursive tables, which are detailed description of the categories values for one variable. A frequency table most often includes all of the following. Absolute frequency. This tells you how many times a particular category in your variable occurs. This is a tally, count, or frequency of occurrence of each individual category or value in the table. Relative frequency or percent. So from absolute, we have relative frequency. This tells you the percentage of each category value related to the total number of cases. Third one, we have cumulative frequency. This is simply a accumulation of the relative frequency for each category value. It's really from top to bottom or bottom up. Okay, the theta command for frequency is pre or tab. So this is for some statistical software. Before you use the pre command, you need to install it onto your computer. So you need to type the following command. What's this? ssc install fre. Okay, we should install the fre command onto your computer. For a frequency table of variable name class, type either fre class or tab class. This is not MATLAB. I'm not sure what statistical software is this. I'm not sure if SPSS, maybe, or maybe Excel or SPSS. Anyway, we have here a table that provides an example of a frequency table for an ordinal variable. Note this is ordinal because the categories are qualitative and ordered. So for example, name, socioeconomic class. If there were numbers of each category that were also ordered, we could treat this as an interval variable. For example, table 1, frequency table, socioeconomic class. So we have class, socioeconomic class, frequency, percent or relative frequency, and then cumulative percent. For example, the upper class would have 50 values, which is 7.14%, and then cumulative is 7.14. The upper middle, we have 150, then 21.43 for the percent, and then the frequency is 150, no? So then the cumulative percent is 28.57. The middle class will have 300 for our families that are involved in the study. So 300, then the frequency is 42.86 or the percentage, then the cumulative percentage is 71.43. Sige. Sige, mas maganda siguro kung ano siya, no? Kung tabular na maganda pagka-present. Sige, gawin natin siya mamaya. Sige, with this, tanong ko, paano nakuha yung, okay, sa example, yung frequency na 21.43, for example, percent for upper middle. How did we get that? Ano yan? 1, 2, 1, 2, 3, 4. 4, 4, 6. Okay natin. How did we get 21.43%? Sinong maka-suggest? Oh, wait lang ah. Ah, what happened? Frequency yun. Okay. So, ayusin lang natin. Ay, okay. Okay, so gawin ko na lang siya later. So, pero, uh-huh. So yung 21.43 would be the frequency over the total, no? So we have ang frequency natin is 150 over the total, which is 50 plus 150, so 200 plus 305. Ayun, the total is 700. Nasa baba, nasa dulo rin pala. So it's 150 over 700. So we have 21.4. Okay, so I'll just do this later na lang, no, para mas ano kasi ma, mas uh, mas understandable kasi okay, naka-tabular siya. So yan yung mga concepts ng visualizations, no? Making the data be be presented, ito pala rin, presented in an understandable manner. Anyway, so we have also cross tabulation. This is also referred to as a group frequency table for two variables. A cross tab simply represents the absolute frequency broken down by categories of two or more variables. It is also possible to find percentages in these types of variables. For instance, using the example below, we can find the percentage of young people that listen to music. So what's the percentage of young people who prefers music? Anyone, guys? So it's 14 over the sum of all the categories, no? 14 over the total of all, no? Not just of the row, but the sum of the rows. The total of the rows. Excuse. Then we have measures of central tendencies. These are what we compute, or we compute these for our quantitative methods in the descriptive statistics. Measure of central tendencies. Measure of central tendencies provide the most occurring or middle value categories for each variable. So there are three measures of central tendencies. We have the mode, the median, and the mean. So the mode would be the highest number of occurrence. The median will be the middle value when ordered, and then the mean would be the average. Measures of variable is okay. Measures of variability. Measures of variability is defined as dispersion or deviation away from the mean for each variable. Measures of variability only exist for interval level variable. There are three measures of variability. You have the range, standard deviation, and variance. A discussion of each can be found below, followed by a summary table. The range is found by taking the highest value of a variable minus the lowest value of the variable. Standard deviation. The standard deviation exists for all interval variables. So it's the summation of x minus mean squared over n, or n minus 1 kapag sample population. It is the average distance of each value away from the sample mean. The larger standard deviation, the further away the values are from the mean. The smaller the standard deviation, the closer the values are to the mean. Suppose you pass out a questionnaire asking randomly selected individuals to rate the former President Obama's job performance on a scale from 1 to 10. You find that on average, this individual gave the president a rating of 5.8, and this variable has standard deviation of 1.2. 1.2. This means on average, his rating of the president is approximately 1.2 away from 5.8. Variance. The variance is always going to be the standard deviation squared. The variance cannot be interpreted as meaning anything other than the standard deviation squared. So the standard deviation pala would be the square root of summation of x minus x of mean squared over n. All over. So yun yung standard deviation. The variance would be without the square root. Okay, summary of univariate statistics. Univariate variables, descriptions, statistics. Mode would be usually for nominal, ordinal, and interval. The most frequent, okay, sabi nga natin, the most frequent category or value. Median would be for ordinal and interval. So median would be category value lies in the middle. Mean would be for interval variables only. Value that represents the average. Range would be for interval again, highest value minus lowest value. So deviation, interval, on average, how much in each individual or deviation value is dispersed around the mean. Variance, interval, variable again for variance, standard deviation squared. That's the definition. Okay, so that's it for the introduction to statistics. Okay. Then we have probability and random variable. We still have time. Tama ba? Okay, sige. So, wait lang. I'll prepare the slide. Okay, so this is from Sir Prost Nabal, my professor in intelligence system. Anyway, so nandiyan na naka-indicate naman yung name niya. Sige. Sir Prost, again, your slides. Statistics review. So we have sample spaces and events, random variables, some important discrete and continuous distributions. Then we have marginal distributions, conditional distributions. Okay, and then expectation. Okay, hanggang conditional distributions lang tayo. But yes, pero you can study the other topics. You may use that in in kasi my subject here is for intelligence systems. No? So in case you want to work on AI, do AI. So you might use the topics 6 to 11. Okay, wait lang. Ito pala. Okay, so sample spaces and events, random variables, some important discrete and continuous distributions, marginal distributions, continued conditional distribution. So 1 to 5 lang tayo. Oops. Sample spaces and events. So, okay, so sample space or omega, so that symbol is omega. It's the set of possible outcomes of an experiment. So the point small omega or yung parang W natin, points are elements of the big omega. The points of or the points small omega, these are the sample outcomes or elements. The subsets of omega are called events. Okay, so subsets, ibig sabihin, A is a subset of B if all the elements of A are in B. No? For example, so we toss a coin twice. So that's the sample space would be head, head. The first toss is head, second toss is head, or head, tail, tail, head, and tail, tail. Okay, event that the first toss is head is A. So head, head, and head, tail. H, 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 T. So H, H, and H, T are in omega, no? Omega. So A is a subset of omega. So A is the event, okay? Omega, all possible outcomes, no? Sample spaces and events. Let small omega be the outcome of measurement of some physical quantity. Example is temperature. So our omega would be the set of all real numbers or from negative infinity to positive infinity. So we can okay, but our omega, the real numbers, is not accurate because temperature has a lower bound. But no harm when sample space is larger than that. Event A that so another example, event A that measurement is larger than 10 but less than or equal to 23 is, so open parenthesis 10 to 23 close parenthesis. Square bracket pala. Close square bracket, closing square bracket. So another example. So we toss a coin forever. Of course, the question would be, how long is forever? Of course, but that's not our point as of this moment. So you can do that in your philosophical analysis. Okay, so omega is equal to small omega, which is equal to small omega 1, comma, small omega 2, comma, small omega I, dot, such that small omega I is an element of HT. So for example, event E that the first head appears on the third toss. So we have E is equal to small omega equals to small omega 1, small omega 2, dot, small omega I, dot, small omega 1 equals to tail, small omega 2, tail pa rin, and on the third toss, it's head, and then small omega I is an element of HT such that I is greater than T. So we're able to notate the event E, or we were able to describe E na mathematically. Okay, sample spaces and events. Okay. Oh, wait lang, I'll just have a water break.